That's totally chill.
Hi.
CJ.
Hi. Hi. Hi.
Hi.
Sorry, guys.
Hi.
Hi. You gonna help Mama do math?
Yeah, he thinks he's going to.
Are you reading?
Got a book?
Sorry. So is grandbaby visiting or do they live with you?
We have an apartment downstairs.
Oh, nice.
So they're living in the apartment downstairs.
How
So I
fun.
get to see her. Yeah,
Yeah.
she's fun. I love
Awesome.
being a grandma.
Yeah, so do I. Okay, back to the quiz. I'll shrink you down here.
Okay, number 3.
All right, so I can't see you guys, so if you're making faces at me, now's the time.
Sleepy.
Number 3 is the third choice.
The third one?
Yeah.
Zero.
No. Shh. Mommy.
You got to be quiet so Mommy can hear her.
All right, number 4.
Okay.
A residual is the difference between the observed value y and the value predicted by the regression line. I think.
Daddy. Welcome.
Equals observed minus predicted. What do you think?
The third one down, is that what you got?
That's what I think it is. Courtney?
Yeah, I think I'm going back over, and I think that's what it is. That's what I had it.
Daddy. Daddy.
Now back to my quizzes.
Mommy.
Oh my gosh, I think I'm gonna be able to see everybody. Okay.
Residuals is an observation is defined as a difference between the observed y and the value that would be predicted by the regression line.
Yeah.
Yep.
All right.
So,
A
yeah.
plot of residuals supports using linear regression when? Is the regression the megaphone one?
Bye. Shh.
The residuals.
Okay.
A residual plot is a scatter plot where the x-axis shows independent variable and the x-axis represents the residual. Okay.
No, it's not the megaphone. It's no megaphone shapes. So the residuals.
A megaphone shapes when there are several patterns that could arise in a residual plot. Curvature, megaphone, and outliers.
So you think that's the one? The question says, where's Michelle?
Michelle, I think her computer froze.
Back here, Michelle.
Mommy.
A plot of residual supports using linear regression when okay, so if linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter. If there is a pattern in the residuals, it suggests that linear regression is not appropriate. So the question being, a plot residual supports linear regression when you see a megaphone shape in the residuals.
Right.
For the next 8 problems, use this data. Oh, geez.
So excited for this.
I am not. Okay.
I don't have enough room on my computer for all of this. All right, I'm going to shrink you guys totally. I'm going to go to math self-efficacy.
Okay, so open up this. The confidence variable is explanatory. Copy. Now I gotta open up the right plot thing.
All right, math self-efficacy.
Open.
Use the confidence variable as the explanatory variable and the score variable as the response. Confidence as explanatory. So that's X, right?
Yeah.
Is Michelle still with us?
Yeah, I'm still here. I'm just trying to get everything
All right.
pulled back up.
I'm trying to get rid of all my extra crap on here because this is not working. Not too much Excel.
Oh, I love this.
Okay, so the math is copy. We'll do a linear regression. So this is.
And then
I don't know
the
how I did statistics without a computer last time.
Okay, what's the other numbers we're using?
The
and then the score.
The score.
yeah. All right, here we go. I gotta find the question again. Compute the residuals for the data using software. What statement best describes the residuals?
So copy.
Okay.
A little bit of form to it. I think that they form a linear pattern, given the options of answers.
It looks like a hot dog.
Well, it's like it's going up and it's positive.
It's
Yeah,
definitely
it's a hot dog, so it's linear.
second choice. Oh my gosh.
Based on the
QQ
QQ,
plot.
what can you say about these residuals?
Which ones do we use for that?
To use the QQ plot, you have to go,
The residuals.
yeah, and you have to go
Right.
into
Yeah.
quantitative descriptive. QQ plot. Clear content. Oh my gosh. There's just
You know what makes me the
so
most
much.
upset about stupid instructor in my
sorry.
other class? 3-point assignment. Sorry. All right. QQ plot tells us that it is distributed. Fairly normal.
You know, it's a big blob.
You got to put them in order from smallest to greatest.
Oh, yeah.
We take the residuals, right? And then that's what
Yeah.
we put into the other one.
Yeah.
Yeah, that's pretty normal.
Yeah, pretty
Copy.
normal.
So it'd be the second
Scatter
one.
plot.
Mm.
Yeah.
Sort.
Sort, but I'm having a hard time reading the work.
Oh my gosh.
So we have
Base. Okay. Now sort. Yeah, it's
Well,
normal.
then you got to go back to the other one.
and we do the X and Y variable for the scatter plot.
Yes.
Uh-oh. Oh, you guys, my numbers are so off.
Okay.
Oh, shoot me now.
Use the software to create a scatter plot of the data. Again, the scatter plot, residuals, plot, and Q. What the freak?
I have to redo mine. I don't know what happened. I have twice as many in my Y column as I do my X.
How do you create the scatter plot?
You highlight your X and Y's and go up to insert.
Oh, okay.
Girl out here. The confidence mean was the X, right?
Come on.
So mine doesn't have that 0 and then have the line go across it. Did you get that when you did your scatter plot?
I don't have the line, And I
have
don't
it
know if I can get the 0 though. I get the 0. It looks different.
Mine's not like it should be.
I'm highlighting my X's right now. So
You have another option for charts.
So I just go over to the scatter plots and it said just to choose the scatter plot.
So I'm highlighting X and Y. And then I go to
do we highlight
insert.
them together or individually?
No, it's
Together.
on mine it's together. It's the first thing for my scatter plot.
Well, that's what it was when I did it before, but now I go in and it gives me something.
Yeah, this is different for me as well. What the heck? This is not what I got on my homework. So insert a chart.
It's the same, pretty much the same exact one that's already posted on there. There's
Yeah,
already a
but it's not supposed, it's supposed to look like, let's see if I've got it's supposed to look like this bottom one. Can you see that?
With the
Mine
line.
doesn't look like that.
That's all for my homework, that's all I got. But this one that it's coming up today is not the same.
Yeah, mine's not the same either.
Look at that. They're like the exact same.
Yeah, that's what I'm coming up with. Is that what you're coming up with, Kelly?
Yeah, I can't even find the chart that has the 0.
Huh.
Are we entering the right information? It's supposed to be the X and Y, right?
That's what I thought. That's what it had us do on the homework.
Eat them. Hey, pick them up and eat them.
It's just so weird. There's no way that our charts have changed.
Why would it have done that? Why would it have changed?
I don't know, because even when I click on it, it says compare at least 2 sets of data, show the relationship. It's even saying it's the same. Oh, no. when I switch to, there it is. I got it this time.
How'd you get it?
I just kept trying.
What did you?
So, okay, so I highlighted X and Y, and I went to insert, and then I went over to chart, and I toggled between, I have 5 choices for a scatter plot, and the first one does not have a 0 in the middle, but the one below it with the lines does. I just toggled between the two, and then it popped up. I just kept checking back and forth. This is dumb. It's like just a glitch.
Yeah,
Where's
because I
Courtney?
get like squiggly lines in all of them, except for the first.
Yeah, so I got the squiggly lines, and then I just went back to the one without lines, and then it popped up the right grid. But
Well,
you know what, Michelle? This doesn't do me any good because I don't know what to do with this information now. I get lost here.
So is it on that line? Does it show that it's pretty much on the? It should be. It should not be like a megaphone.
Right?
Does it look like that at all? Or is it just kind of all over? Because if it's all over, that's what you want.
Yeah, I don't think this is megaphone looking at all.
This is
And
what
what
I
are-
want.
Hold on. What?
I don't know what it's doing.
What the heck is that? Why do you have a straight line at the bottom?
Heck if I know, I just entered a scatter plot.
How'd you get color?
Don't know. I went up here and I did insert, charts, and it gave me 2 different scatter plots. There was this one or this one.
So you should use a scatter plot that has a 0 in the center of it, going horizontally.
Yeah, I can't get mine to get the 0 in front of it.
That one?
Hold on, let me look. Oh, shoot. Gotta make you bigger so I can see it. No, it starts at like -40, -20, 10, 0, 10, 20, 30 up the y-axis.
Huh. I don't even know how to get that one then. Because those are the only 2 options for scatter I have.
Well, no, you got 1, 2, 3, 4. You got 5 or 6 options. 1, 2, 3. You have 5 options. The other ones don't work, but yeah, none of yours come up the same. How interesting. All right, what's the test question? Maybe we have enough information. Use the software to create a scatter plot of the data. Given the scatter plot, residuals plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data?
Has nothing to do with all the work it just put us through.
So, oh shoot, use the software. Given the scatter plot, the residuals plot, and the QQ plot. So those are the first 3. So for the residuals plot, I don't think there's a megaphone shape, but I could be wrong because it's kind of hard to tell sometimes. For the QQ plot, points in the QQ plot are close to linear or close to the line. That's true. And for the scatter plot, it's a hot dog shape.
Mm-hmm.
So holy crap, you guys.
No.
So the last one, the observations are independent. That's not something we're worried about. The X values are measured without error. We're not worried about that either. The residuals are normally distributed. The variance of the error term is constant for all values of x. If there's no megaphone shape, then I think that's true. There's a linear relationship between x and y, that's true. The residuals are normally distributed.
It's between the first and the third, isn't it?
You mark all that apply.
Oh, mark all that apply.
Yeah.
So I think it's the first and the third are true.
Right, and I think the second's true because that's the
Okay, here you go.
the normal error term.
I'm going to read you the requirements. The first one is the linear relationship. How to check is a scatter plot, and it's supposed to be a hot dog shape.
Right.
If you do a residual plot, there's supposed to be no pattern in the residuals.
Right.
Number 2, normal error term, QQ plot of the residuals. Points in the QQ plot are close to the line.
Right, that's true.
Number 3, constant variance, residual plot. No megaphone shape in the residuals.
I don't think it's a megaphone shape, but what do you guys think?
I can't get it up on my computer to find out if it is or not.
Because for me, it looks like it. So yeah, look at my fingers. It looks like it. Hold on. This is kind of what. Oh, this might not be dark enough. So it kind of spreads out a little starting here. It kind of spreads out a little going up and down, but then there's a lot right here in the middle beyond where it spreads out. So I don't think that's a megaphone, because I think a megaphone would spread out and the majority of the data would be here. It spreads out, but on this particular scatter plot, it spreads out, but then it comes back, and then there's a lot in the middle again. Tube with a little bit on the outside, but not at the end.
Okay. The fourth one is x's are known constants.
Yeah, those go with the fourth and fifth, and we're not doing those right now.
Yeah.
I don't think those are options for us.
So I think
if we agree that there's no megaphone shape, then it's the first 3, I think. And I'm willing to submit it that way and see.
Number 5 is observations are independent. Do we know that? Knowing the value of y's tells you nothing about any other points.
We're not doing that one either right now.
Okay.
Just let's try to submit it with the first 3.
Well, maybe
I'm not
maybe
sure about the second one. Why would you think that would be true? I guess is what I'm questioning.
The normal error term.
The variance of the error term is consistent for all values of x.
Because when you use a QQ plot, if all the points are close to the line, then that's true. Then the requirements have been met. So that's the one I'm for sure of. Watch it be wrong. So from the data we have, that one is like, oh yeah, okay, I'm good with that one.
Okay, and I think that the first one, I'm pretty confident that the first one's right. And
there is a linear equation between the two.
There is a linear relationship.
Yeah, because do you think it's a hot dog shape? If you drew a line through it, there would be data on both sides of the line. right? So then for the constant variable, there's no megaphone shape in the residuals, I don't think. But now that Courtney read it out loud, maybe the last two we need to consider also. What are these? What are the topics we're looking at?
We're looking at the scatter plot, the QQ plot, and the
No, I mean in our data, it's a score and a confidence rating mean. So does knowing the value of one tell you anything about the other?
Can you send us to check out all of these plots, and all these plots are in the requirements.
What?
So,
What was that, Courtney?
oh, it's telling us use the software to create a scatter plot, the residuals plot, and QQ plot.
Yeah.
And the requirements use all three of those.
well, the last two. Do you remember that chart he did on the video? The
Yeah,
last,
that's what I'm looking at.
yeah, the
So
last.
the requirement for the observations are independent is that knowing the value of the y's tells you nothing about any other points.
Right, I just talked about that.
Very last one.
And that's
The
what I just
values
asked you.
measured accurately and precisely. Those ones cannot be directly checked, but x's are known constants for that one to be met.
So it's true that x's are known constants because it's the score. Right, no. The x is the confidence rating mean. And so I don't know if that is constant, is it?
Yeah, but he also said that they should be gathered independently of each other.
Yeah. The observations are independent in such that knowing the value of one y tells you nothing about any of the other points.
So do you think it's all five? Do you think everything is met for this?
I'm not sure.
I'm not sure either.
See, I think it's only the first three because in the video he said we're not going to worry about the last two right now.
That's what I remember him saying in the video. That's why I'm saying I wonder if we should just leave those
That's my thought.
two.
All right, let's move on. I'm going to mark the first three. All right. The B1 estimate for the slope.
So it'd be
12.625?
Yep.
Yeah.
The lower bound is 10.674. Right?
Maybe.
Of the confidence interval.
Yeah.
Okay. And then the upper bound is
Wait,
14.
no, is this at 95%? Okay. Sorry.
I don't have. Oh, yeah, the confidence interval right there is the 10.674. Okay.
Yeah. And then 14.715.
I did something backwards. Hold on, I gotta paste this.
So if we're going for the p-value is actually 0 because it's got the number.
Yeah.
Or not the number, but the letter in it. So it's low. So we reject. I'll never get those right. Okay, we reject and have some.
No, because it's the third one.
Yeah.
For a hypothesis test,
That you have sufficient evidence.
Hold on.
If
So I wrote this down. If you reject the null hypothesis, what does that mean? It means that we have sufficient evidence to say that there is a linear relationship between, oh crap, that's not a choice here. There's sufficient evidence to conclude that the slope of regression line is 0, or there's sufficient evidence to conclude that the slope of the regression line is not 0. And we're going to the not. We compare this to the alternative, which is not equal to 0.
So the last one.
Fourth choice, yeah.
Oh my gosh. Okay.
Okay, let's go back to these dang crocodiles.
Body length is the dependent because it uses the head length. It depends on the head length.
What?
For the data, the variable is depend. Which one's the dependent?
Body length is dependent because it's dependent upon the head length to predict its length.
But how do you know that? Oh, head
It
length
says right
was
here.
used to predict body length. Okay. So, which is the dependent variable? Body
Body
length.
length. And the dependent is, that's the Y, right?
Yes.
Okay, now I got to
Okay.
copy all this crap over.
Yeah.
So the body length goes in X? Or
No, Y.
Y. Because that's what we're trying to determine.
Mm-hmm.
Okay. This actually isn't too bad. It's just getting it in, switching through all these things.
Body length. I still think we should do a group exam for the final, really.
This is just torture.
We work way better together as a group. Petition her.
Okay, so for this one, you want to take the negative 18.274 plus 7.660.
Hold on. Where are
Is
you
that
coming up
right?
with these numbers? I'm getting ready to paste everything, so I don't have numbers yet.
I
Oh,
don't even know what the questions.
I'll
Construct a 95% confidence interval for B1. Isn't it given?
I don't know yet. I'm almost done.
Oh, the margin of error. No! I hate the margin of error. We are supposed to be done with that.
So is number 5 the third one down? That's the only one. I think I missed that one because it's
Number 5?
yeah.
The third choice? Yeah.
Okay.
That's what we're guessing.
Okay, so what are we supposed to do right now?
We're looking for margin of error.
How the heck do you do that again?
You are asking the wrong chick.
I will look it up.
I can do the lower bound though.
Oh my gosh. Notes. Margin of error is going.
To make me want to cry.
It's the upper bound minus the lower bound divided by the square root of sample size.
Well, we don't even have that information, do
Yeah, we do. It's all given to us.
Where?
Your confidence interval is 7.218 and 8.103. And your sample size is however many we have over here. Mine starts at 4. So
Where was that formula at?
39.
Was that in our previous lesson?
The margin of error?
No, that was like way back.
I need to write that down. I need to text that to myself. So it's what?
I think it's
Yeah,
the
keep
lower
laughing.
bound minus the upper bound divided by the square root of the sample size, which I think is 29.
So it's the upper bound
The lower bound
minus
minus the lower bound.
lower bound divided by square root of n.
Yeah.
Okay.
And if Sister Wilkinson is watching us, she's probably cracking up
That's okay. I just texted myself that.
because I don't know if this is right. So
Okay.
it might be minus.
Well, hold on. If you have a 95% confidence level, isn't that 1 point? Oh my gosh. Okay. So it's 1.96 is your confidence, right?
Well, is it? So don't we have the confidence interval in the data here? We're not doing
Yeah.
the confidence
So is
interval
it?
given.
So
Confidence-
it's 2.212 minus or plus, I guess in our case, because a minus is that plus 38 point.
Oh, I was using B1.
Yeah, you have to use the bottom one. You have
Oh,
to use 7
Okay, ha 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 ha.
and 8.1.
103 minus 7.218. Right? Yeah. Equals divided by the square root. What's the n is? Where are you?
29.
So
The n is 0.9?
29. How
Oh,
many
29.
samples?
The divided by the square root of 29. So I got 0.164.
Negative, right? So you subtracted the lower bound from the upper bound?
Oh, it's a lower bound from the upper bound?
No, that's what I'm asking if you did. I subtracted the upper bound from the lower bound.
That's what I did.
Then you should get a negative number because the upper bound is larger. Okay, hold on. T star times S divided by the square root of N. The margin of error for confidence intervals.
I did 8.103
That's the upper bound.
minus 7.218.
Yes, so you're subtracting the lower bound from the upper bound, but I think we're wrong.
you're supposed to subtract the upper bound from the lower bound, right?
No, I think it's what you were talking about, Michelle. T star times S divided by the square root of N. Except then we'd have to know the standard deviation. We don't have that.
I want to cry.
Oh my God.
Well, isn't that okay? So is it a confidence interval for one proportion? No. Right?
No, there's two different proportions.
Confidence interval for two proportions. So, let's see, what does that say? So it would be oh my gosh. Okay.
So we don't have the standard deviation, guys, so I don't think we're looking in the right spot. And I'm trying to find my notes, but I think I'm going to have to look somewhere else because
So would
the
it
one
be in lesson 18? Is that what we're looking at?
lesson 18. Lesson 18.
Confidence interval for two proportions.
Yeah.
So that P1 minus P2 or P hat 1 minus P hat 2 plus or minus. So it'd be Z star.
Times the square root of p hat times 1 minus p hat divided by n.
Is that that?
Oh, do we have p hat?
Oh, we have Y hat. And we have
I
mu
want to
hat.
cry.
Okay, I think you guys were overthinking this. Let's look at the information that we do have.
So for B1, we're solving for B1. We're solving the margin of error for B1. So
Which is the slope.
we have the t-score, we have the p-value, we have the confidence intervals.
So we're not looking for the desired margin of error. Oh my gosh. You know, we could have a whole note page on margin of errors only. I'm a margin of error.
It's got to be. It's probably the other one that I can't find, but this sheet here.
Hold on, let me look. Hold on. Yeah.
Okay, so where's the other one? I can't find my other one.
Oh, quantitative versus categorical.
Yeah, would that margin of error be on that?
Oh, it's upper bound minus lower bound divided by 2.
Upper bound minus lower bound divided by 2.
Yeah.
4.494.
What?
4.494.
Okay, if we're wrong, I'll send you guys flowers. No, that's not true. I think, Michelle, we're overthinking this. Given the information we have, that's the simplest formula we can use.
Okay.
Do you understand?
Yeah.
Unless she really does want us to go through and get the standard deviation and stuff, which I can't imagine she wants us to do for this assignment. Maybe on the test.
Probably.
4.494, right?
Yeah.
Then number 16 is 7.218. Number 18 is 8.103. Number 18, based on your lower and upper bound from the last two problems, what can you say about B1? We're 95% confident the confidence interval will contain the true value of B1.
Yeah.
The second one is not right. The third one is not right.
So number 1.
There's insufficient evidence to reject the null. What's the null in this? Crap. Do we have a null? We don't even have a null.
Okay, I'm going to submit it.
Are we done?
Yeah. Number 6 is wrong.
Ah!
Number 10.
Crap.
Oh no, hold on, never mind. Just playing. Don't take that.
Ah.
Number 15.
No. I was so sure.
We have 3 wrong. So 15. Six. 5.
5?
5?
Crap.
Yeah.
Oh, it's not the megaphone shape. The plot of residual supports using linear regression when
So 5, 6, and 15.
5, 6, and 15.
well, when you're looking at a residual graph, you do not want to see a megaphone. That's bad. But
Right.
you want to see when all the dots are all over the place.
So do we want to see a pattern or not?
I don't think you want to see a pattern. I think it's all over, isn't it?
Yeah, but that's not a choice.
Yeah, I know.
Do the residuals all have to be positive? I don't even remember that.
That's what I'm thinking, but I don't know. I don't remember reading that.
The residuals look normally distributed.
Do you see that somewhere?
That's one of the options.
On the test, but is it written in the book somewhere?
Let me see.
Residual plot shows random scatter. There is no obvious pattern to the data. If linear regression is appropriate, then a residual plot will show no patterns and will consist of random scatter. If there is a pattern, it suggests that linear regression is not appropriate. It's none of our choices.
I wonder if it's A. Because it won't show a pattern. It won't be the megaphone. And it says nothing about the positives. So it has to be just normally distributed, which means if it's normally distributed, it's going to just be all over the place.
Okay, positive or negative.
That's what I'm thinking, because when you read it, it didn't say that it had to be positive or negative.
No. All right, so I'll put that one. Number 5. So number 6. Compute the residuals. Crap.
Okay, so this one is the one that I couldn't get up.
The math self-efficacy. Not math self-efficacy. Okay, so
So number 6 is which one?
well, so I'm gonna have to do the problem over again because I already wiped it out to do the next one. But I don't recall the residuals all being negative. Do
So
you?
the only other option is the residuals are between negative 40 and 25.
Right, but do you recall if they were all negative?
No.
Okay, so here's the deal, guys. Only
Hold
one
on.
of us is going to submit, and there's only 3 choices. So by process of elimination, we'll get it.
Okay.
So I'm going to mark 1 again. So now we have to go down to the stupid margin of error. Oh, gosh. If I die today, somebody needs to call my husband and make sure he puts "she just didn't know the margin of error" on my tombstone.
So I'm wondering if that 95% confidence, I'm thinking we have to use the 1 point, I think it's back. I don't know. I'm guessing at this. I have no idea.
So for 95%, right? So 1.960.
But I'm not seeing where I specifically pointed out this is the thing.
So
for
in lesson
margin of error.
17 is when we started doing the sample size for desired margin of errors. So solid margin of errors was well before that. Z star times the standard deviation divided by the square root of n is one formula for margin of error for one group. Upper bound minus lower bound divided by 2 is a formula.
Do you remember that sheet that I showed? This one? Do you have the other one?
Yeah.
Okay, so I think we're going off that other one, are we not?
So which sheet do you have? Which sheet do you have in your hand?
It's the
Proportion or means?
quantitative. So it's the sigma unknown, the T sample, the ANOVA test. So it's the other one.
So you want the other one. Okay, so I'm looking at the other one.
So on there, on the formulas, does it give a margin of error?
No, and I don't have any margins of error. Oh, yeah, hold on. Okay, so the only formula is under the one sample Z for one group, one variable. And it's N equals Z star divided by M times, squared times P star times 1 minus P star.
Huh?
I can show you, but I don't know if it'll show up.
Hold on, let me pull my.
Is that clear?
It's up. So it's that Z star, the square root of P, 1 minus P. Is that what we need to use? Because it's everything after the plus minus.
That's a different formula. That's the everything after the plus minus. Hold on, that's right here. So Z star times the square root of, in this particular one, it's P hat times 1 minus P hat divided by N. Or yeah, Z star times the square root of P hat times 1 minus P hat over N. And that's the one where you're talking about everything on the other side of the plus or minus.
Yeah, it would be lesson, is it lesson 17?
Yeah. Yeah.
Okay, but that's for one proportion. And then they have one for two proportions. So aren't we doing a two proportion?
That's my thought. So the next, so after we did that, the next margin of error thing that we talked about was doing a sample size for the desired margin of error. And that's where we had 2 or 3 different choices. And then for lesson 18, so we were talking about estimates and the proportion, sample proportion.
So is it N equals Z star over M to the square?
That's another way to get that margin of error for a one group, one variable.
One group, one variable?
Yeah.
Oh my gosh.
Wow. I would give for a monkey to do my homework right now.
I have no idea.
I know, I just don't, I mean, do you think we need to break this down and start from scratch and work it out? Like, to get the standard deviation?
It's got to be easier than that.
Oh my gosh. Courtney,
Yes, I am
what
trying
did
to go
you,
back through my
did
emails
you-
so I can look at those charts because I don't know where my charts are right now off the top of my head. I'm
all right,
getting
listen, what answer did you put for number 15? Because I have a different answer.
4.494.
I'm doing the math and I get 0.4425. Which, if you round up to the third, would be
You get what?
0.444. I did that math, and I get 0.4425.
443. So it'd be 0.443.
Yeah, 0.443.
You can try it with that.
Michelle?
You want me to try it?
No, I don't care. What do you think? Should we?
I don't know. To tell you the truth,
All
I
right,
don't
I'll
even
submit.
know what formula to use now.
I think it's the simple one because we've got the confidence interval right in front of us. I truly think it's simple.
So is it
So we
point?
changed 0.443.
Okay.
So we changed the other two to the first choice each. Numbers 5 and 6, right?
Yeah.
Let me look.
All right. Make sure I did it. I wrote it down. 5
Do you
is
want
the
me to
first
submit and see?
I'll go for it.
Okay.
Taking the fall in a while.
0.443, right?
Yeah, that's what I'm putting. But don't submit yours yet till we know.
Oh, I'm not.
Now I have to find the exact spot on this go to submit button to make it work. Because all right. I got number 1 right. One that's funny.
What?
I got number 1 right.
Good job.
All right, number 5 is right. Number 6 is right.
Now we need number 15.
I'm getting there. Score. We did it.
We did it?
Yeah.
So
we just did the math wrong.
what did you do? What was the,
So you
How did you
change.
do number 15?
So number 15 is the upper bound minus the lower bound divided by 2. Take that, Sister Wilkinson. I did remember.
Upper minus lower divided by 2.
Upper minus lower divided by 2.
Okay.
Okay. All right,
So we
good.
did an answer like this on our last quiz. It was, you know, just asking something from a long time ago. And I'm like, there's no way. I'm never going to remember this. So I was looking through my notes and my original notes got destroyed. So I had to rewrite them. And I didn't have everything I probably should have had. So I just like, all right, this is so simple. So I went with the most simple of answers. Like, it worked.
Oh my freaking
So-
heck, you guys. I forgot to enter number 17. And I submitted it on accident.
What?
Yeah.
Well, 17
Dad, no.
was it. You're good. You still got a good grade. It's
I
just
only missed 0.5.
0.5.
And you did it right. That's the more important thing.
So what did you
Okay,
get?
so it's the upper minus lower divided by 2.
Yeah.
Upper minus lower divided by 2.
Yeah.
Oh my gosh. Okay.
And you guys, no lie, I went with that because we've got the information given to us. We're not, you know, if we had to figure out the standard deviation, then I'd start thinking, oh, this is going to be a different problem. But we weren't asked to do that. So here's all the information we have. So what can we do with the information we have? Now, for the test, it might be different. She might want us to start at the bottom for that.
Yeah, I'm sure it will be hard. So are you
Yeah,
planning
so
on being there Friday at 9 then? Because she has the review at 9 a.m. on Friday.
I haven't seen that. When did that come out?
It was on the,
On her information?
I think so.
Okay, I'm definitely going to do it then if it's at 9 on Friday.
Yeah.
Heck yeah, I got to do it. If I go from my grade now to a C because I bombed one test, I will really want to hurt myself.
Yeah, that will be miserable.